Good morning. Work and energy. Now we can look at two another forms: work done by a uniform force and work done by a central force. First, work done by a uniform force. According to the definition of work done, we know that WFI is equal to integral from Ri to Rf F dot dr. If work force is constant, that is, we are applying uniform force, we can write F is equal to uniform constant value into a unit vector n, where n is the direction of particular vector f. Then WFI can be written as integral from Ri to Rf F dot F into cap n cap dot dr. It is equal to F0 into n dot integral from, in place of Ri we are writing as xi, yi, zi, and in place of Rf xf, yf and zf. Dot dr can be written as the components of dr, I dx plus j dy plus k dz. Here I, j, k are unit vectors in mutually perpendicular directions. Therefore WFI can be written as f0 into unit vector n dot I into dx. While integrating dx we will get x, and applying the limits, that is upper limit minus lower limit, we will get I into xf minus xi plus j into yf minus yi plus k into zf minus zi, and can be written as WFI is equal to f0 into unit vector n into Rf minus Ri. That is f0 into unit vector n. This is the component of dot product f0 cos Rf minus Ri. It shows that for constant force, the work done depends only on the displacement, not on the path followed. Here it is depending upon Rf and Ri, the endpoints. Rf and Ri are the endpoints of the displacement, and it is independent of the path followed. This is a case of work done by a uniform force. Next we can look at work done by a central force. Central force, a force which acts towards or away from a particular origin, is called a central force, and it can be mathematically written as f of r is equal to f of r into unit vector r. Here the motion of the particle is confined to a plane. So in the case of a central force, the motion is along a plane. Then the work done WFI is equal to integral from Ri to Rf F dot dr can be written as f is replaced by f of r into unit vector r. That is integral from Ri to Rf F of r dot dr. And we can write this in terms of the polar coordinates. That is dr is equal to unit vector r dr plus unit vector theta r d theta. These are the polar coordinates of dr. Therefore WFI can be written as integral from Ri to Rf f of r into unit vector r into dr. In place of dr we are writing r cap dr plus theta cap r d theta. R dot r is equal to 1. R dot theta is equal to 0. They are mutually perpendicular. Therefore r dot theta term vanishes. Only r dot r, one term, f of r dr will remain. Integral from Ri to Rf f of r dr. Here the work done depends only on the endpoints. That is, it is independent of the path followed. Such forces are called conservative forces. That is, central force is a conservative force. It is independent of the path followed. It depends only on the endpoints.